Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at synthetic division. So this is an alternative to polynomial division and people usually find it easier. It's used for the same purpose. So we're going to find the roots of this cubic polynomial here. So we can't factorize this easily. It's not the sum or difference of cubes. There's no common factor amongst all the terms. We can't group either. So just like when we use polynomial division, we need to find a root, which gives us a linear factor, and then we can find the other roots. Now it's easy to find a root here because the coefficients, 1, 1, negative 10, 8, they add to 0. So that straight away tells us that 1 is a root. F of 1 is equal to 0, so x minus 1 is a factor. So this is how we use synthetic division. So we write the root here, and next to it we're going to write the coefficients of the original polynomial. So 1 for x cubed, x squared, coefficient of x, and constant term. So we always start by bringing down this first term here, 1. Now whenever we bring something down here, it gets multiplied by the root. So we go 1 times 1 is obviously 1, and then we put that up here. Now, when we're calculating the remainder in synthetic division, we add rather than subtract. So 1 plus 1 is, of course, 2. Whenever we have a number down here, it gets multiplied by the root. So 1 times 2 is 2, and we write that up here. Once again, we add to calculate the remainder. Negative 10 plus 2 gives us negative 8. Whenever we get a number down here, it gets multiplied by the root. So 1 times negative 8, negative 8. And then finally, we add the remainder one last time. We get 0. So what have we actually found? So we've actually, perhaps without knowing it, performed this division here. Now we know when we divide a cubic by a linear polynomial, the answer is a quadratic. These three numbers are the coefficients of the quadratic. This is the coefficient of x squared, x, and constant term. So we've figured out that the answer to this division is x squared plus 2x minus 8. Now that the final number obtained was 0 means there's no remainder, which is what we expect because we knew x minus 1 was a factor. So this is exactly the same result we would have obtained had we used polynomial division. But in synthetic division, we don't need to write all the x's, and that's one of the reasons people find this simpler. So if I want to find the roots of this, I've done exactly what I would do when using polynomial division. So what we have is f of x is equal to x minus 1, our original linear polynomial, multiplied by the quadratic we found, x squared plus 2x minus 8. So once again, we're reducing a cubic into factorizing a quadratic, which is easy. So we just need two numbers that multiply to negative 8 and add to 2. They are positive 4 and negative 8. So the roots of this polynomial are just 1, negative 4, and 2, and we're done. Let's look at another example. So we will use synthetic division to find the roots of this polynomial. Now once again, we need to first guess a root in order that we can perform the division. So we'll use the rational root theorem here. If there's an integer factor, it's going to be factors of 2, positive or negative. So we can try a few of those, and it turns out that f of negative 2 is equal to 0. If you substitute negative 2 for x, you get negative 32 plus 48 minus 18 plus 2, which is 0. So let's perform the synthetic division. So we write the root here. Next to it, we write the coefficients of the cubic polynomial. We always start by bringing down this first number. It gets multiplied by the root. Negative 2 times 4 is negative 8, which we write there. Now we add to find the remainder. 12 plus negative 8 is 4. Whenever we get a number down here, we multiply by the root. So negative 2 times 4 is again negative 8. 9 plus negative 8 is 1. And then when we get a number down here, multiply by the root. Negative 2 times 1 is negative 2. And our final remainder is 0, which we expected. So we found that our original polynomial, which we called fx, is going to be equal to x plus 2. That's because negative 2 was a root, multiplied by the quadratic, and these are the coefficients of the quadratic. So 4 is the coefficient of x squared, 4 is the coefficient of x, and the constant term is 1. So now we can just factorize this quadratic using our usual methods. Hopefully you will recognize this as 2x plus 1 all squared. So this polynomial has two distinct roots, negative 2, and then negative a half is a double root. All right, let's now look at dividing by a non-monic linear factor. Here we're going to divide by 3x plus 4. So the coefficient of x in the linear polynomial is not 1, but we're going to do this a very similar way. So we want the root of this linear polynomial. So that will be negative 4 on 3. That's the value of x that makes the linear factor equal 0. So we write the root there, and once again we write the coefficients next to it coming from the cubic polynomial. So even though we've got a fraction here, we're going to do everything the same way. We're going to bring down the 3. Now negative 4 over 3 times 3 just gives us negative 4. 7 plus negative 4 is 3. Whenever we get a number down here, multiply by the root. Negative 4 on 3 times 3 is again negative 4. 13 plus negative 4 is 9. Now we multiply 9 by negative 4 on 3, we get negative 12. And once again, the remainder is 0. So this is what we found. We found that our original cubic polynomial can be written as x plus 4 over 3. So that's a plus because this has a root of negative 4 on 3. And it's multiplied by 3x squared plus 3x plus 9. So this looks similar to, but not exactly like what we want. We weren't dividing by x plus 4 over 3, we were dividing by this. So what I want to do is I want to multiply this whole polynomial by 3. So that will give me my 3x plus 4. I multiply each term by 3. But I can't just multiply this by 3. I would be changing the whole answer by a factor of 3. So if I've multiplied that first polynomial by 3, I need to divide this one by 3. So I'm going to divide each of the terms by 3. I get x squared plus x plus 3. So if this is equal to these two multiplied together, when I divide this by 3x plus 4, I'm just going to be left with this quadratic x squared plus x plus 3, and once again, there was no remainder. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.